Holy schmoly, calculates. This part's starting to look scary. So, we've been solving differential equations. In other words, going up a level and getting all the way back to the original if we start with y double prime, so that we can find the original function. And as an example of this, so if I have y prime and I want to get back to the original, of course, I can integrate both sides. Now, keep in mind y prime is really dy dx. And I really want to have all the y's on one side and all the x's on the other. So that means that I'm going to multiply both sides by dx, and I will end up having a dx over here, and then of course this will be gone. So really I'm integrating dy on the left and 3x plus 1 dx on the right, which makes sense because on the left, well, I don't have a variable there, but of course we know there is a number, and on the right everything is in terms of x. I'm integrating with respect to x. So now if I go up a level on the left, I'll be back to y, and over here if I go up a level, and then remember plus c. Now technically there's a plus c on the left side too, but really I just take that constant and move it over, and I keep all the constants on one side. And that's why it looks like this. And of course, if you give me some value, I could plug it in to solve for c, but I don't have any information other than what I have. So right now, my function just has to stay generic. So of course, if I take this second one, remember that's really dy dx, and I have 2x and y. And so I'd like to get all the y's on the left and all the x's on the right. And I can make that magic happen relatively easy. Multiply both sides by y, multiply both sides by dx. Oh my gosh, look how easy that was. And so now I can integrate. And on the left side, of course, I'll power up. And I'd have a plus c, but I'm going to put all the constants on the other side. And then on the right side, I'm going to power up and put the c. And then, of course, I can reduce all this and make it look nice and neat and tidy. Whee! Sometimes I make myself sick doing that. And so I have y squared over 2 equals x squared plus c. And if I'd like to get it all in terms of y, I can multiply everything by 2. So I'll have y squared equals 2x squared. Now remember, when I multiply a constant by 2, it just gives me another constant. And then I would have to take the square root of both sides, which would give me plus or minus, and the 2x squared plus c. Now keep in mind, dependent upon what initial condition you have will determine which sign you use. So we've actually seen one of these in class that you did. So that sign is dependent upon initial condition. Well, that doesn't look like initial at all, does it?